unless you were in honors math last year, up until now, your trig has only been useful in what kind of triangle? A right angle triangle. 3 trig ratios are only good for 90-degree triangles up until now. You guys aren't stupid. You're aware that you can have a triangle without a 90-degree in it, aren't you? Right? You're all aware of that, yeah? Okay, so I want you to watch something. You don't have to do anything with this. I just want you to watch something. Just have a look. If I gave you this triangle, and I told you that was 12, and that was 18, and I wanted you to find, and I told you this was 37, and I told you I wanted you to find X. Could you do that right now? I know some of you can because you've done what we're about to talk about. But all of you can. What would you do there? How? There's no 90 degrees. So what would you do to tell me X? What? Can't do Pythagoras. There's no 90 degrees. Well, you know it because you were in honors math last year with me, cheater. If you weren't in honors math last year, what do you have to do here? I don't know that. There are people in here that I did not teach in grade 10. What would you do there?
You have the corresponding side A and A.
Here's what I do. What did I just make? So could I do trig over here now? I can, can't I? And that will give me this distance right here, yes? Once I have that distance there, can I use that and that to find this? And then what would I do with these two numbers? Add them together. So here is what happens. How do I find h there? And I shouldn't use h because h, you guys want to use that as hypotenuse. So I'm going to make that q. How do I find q? What would I do with that black triangle to find q? I've got a theta of 37. I've got an h of 12. And my O is q, yes? So what uses O and h? Sine. So sine 37 equals q over 12, yes? Everyone agree? So what does q equal? 12 sine 37. Is everyone okay with that? Is everyone good with that? Okay. Once I know q, can I use that to find this side down here? I could. I could do Pythagoras, couldn't I? Right? Now, if I come over to this triangle here, which I'm going to highlight in red, what do I know q is? Q equals 12 sine 37, doesn't it? Right? Okay. And I've got an hypotenuse of 18, yes? Here? Right? Now, I'm going to tell this angle right here is a theta. What is sine of red theta? Q over H, yes? What's Q? 12 sine 37 divided by what? 18. Everybody cool there? Everybody okay with that? So now you should be aware that if I do some sine work with one of the angles, and I do some sine work with the other angle, I can use that to find, once I know that, I can find this spot right here. I can find this spot right here. And then what do I need to do with them? Add them. Now, fortunately for us, and fortunately for everybody that was in Honors 10 last year, with me at least, somebody else has already done all this work for us. And they have given us this formula, the sine law. So everybody draw a triangle there. No 90 degrees. Label the corners properly. How do we label corners? Yeah, capitals. A, B, C. Now label the sides properly. What's this guy? Lil C. What's this guy? Lil A. What's this guy? Lil B. Okay? And then, to make this, we need to put in a Q, right? And this is how it works, all right? The sine of A equals what? Q over C, correct? Everyone agree? Okay. What is the sine of C? What's the sine of C? Q over B? Q over A, yes? Is everybody cool with that? Okay. Now, in this question, Q equals sine A times C, correct? Everyone agree? Okay. What's Q over here? Sine C times A. Is everybody cool there? All right. Now, what do you notice about that and that? They're both Q, aren't they? So what does that tell us? If that equals Q and that equals Q, what does that tell us about sine A C and sine C A? They are equal, correct? Everyone agree? Right? Now, if I divide that side by C, and I divide that side by C, what's going to happen to this C? It's going to disappear. If I divide this side by A and this side by A, what's going to happen to that A? It's going to disappear. So that leaves me with sine of A over A must equal sine of C over C. You guys are smart kids. If two things happen in a triangle, what must happen with the third thing? It's got to be the same. Sine B over little b. Now listen to me. This is the way I was taught sine law, with the signs in the numerator. This is the way a lot of textbooks now, 20 years later, write it, with the signs in the denominator. Does it matter? No, as long as you keep it all the way through. If you start with this, you got to finish with this. if you start with this, you got to finish with this. Does everybody understand? All right. So now, let's do this. Am I recording? I am. Good. Okay. So, I have a triangle, ABC, with some measurements. Do you see on my screen anywhere, excuse me, a triangle? So what do I need to do? Does it matter how it looks, Joel? No. Can't be a 90, but it doesn't matter because I know it's not a 90. ABC, angle A equals 40. Does it matter where I put angle A? No, but I'm going to put it here because I like to read left to right. There's 40. Angle B equals 75. Does it matter where I put angle B? The way I've drawn it, since angle B is 75, it's got to be less than 90, yes? So where should I put it, the way I've drawn it? They're both less than 90, aren't they? So does it matter where I put it? That's the point I'm trying to make. No. If I put it here, this is 75, correct? So how big is this angle up here? How big is angle C? How do we figure it out? That's the first bit of math I got to do. How do I figure out angle C? 180 minus 75 minus 40 to get what? 60 exactly? 65, guys. There's a 5 there. 65 degrees, yes? Now, what else do I know in this triangle? Read the question. What else do I know? AB is 6, correct? So now I look to myself and I say, okay, how am I going to figure out X and Y? Well, I have an angle and its opposite side, don't I? So I can use the sine law. Sine of 65 over what? 6. Or I could do 6 over sine 65, couldn't I? Right? What way do you guys have written here? You guys have the side in the numerator. So I'm going to reverse this the same way your notes are. It's hard for me to remember because I was taught when I was your guys' age to put the sign in the numerator. So if you find me reversing them, you need to be aware that it doesn't matter, right? So what is this first one going to be? No. What do I write? X over sine 75. Why is it 75? Because that's what's across from X. Agreed? And I have sine over 6 over sine 65 also equals Y over sine 40. Now, how do you solve that? How do you solve fraction equals fraction? Cross multiply. So it is 6 sine 75 divided by sine 65 will get me X. That is hard to punch into your calculator sometimes, especially if you have a backwards calculator. None of you should have a backwards calculator in this class anymore. But if you do, that's really difficult to punch in. So punch it in carefully. What's Y going to be? Six sine 75 for Y. 6 sine 40 over sine 65 will equal Y. And now what are my two answers? So 6.4 for which? X, 6.4. And for Y? So 4.3. How do I know that's 6.4? How do I know that's over here? What in my triangle proves that? Is that the longest side? And is it across from the biggest angle? 65 and 6. Is that the middle angle? Across from the middle side. 40, smallest angle, across from the smallest side. Now the point I'm trying to make here is, would it have mattered if I'd put B up here? No, because then my 6 would have been here, but it would have been the same calculations. Is everybody good? Okay. What does this mean? Solve the triangle. What does that mean? I've left a blank here. What do you have to do if I ask you to solve a triangle? Find all angles and sides. A great many of you often forget one of them. You forget to find one of the angles, or you forget to find one of the sides. Means find all. So how do we do it? We got to draw it. Now, again, this makes me want to stab myself in the eye with a pen. It's not angle ABC. It's DEF. Does it matter? No. Would any of you ever say to me, I can't do that on Myers because it's not AVC and the law says AVC? No, you would never say that to me. Does it matter how you draw it? No. Draw a triangle. I like to make the first angle I see D. That's just the way I like to work it. Now I'm in a bit of trouble, because now, since I've made this guy D, what does that make this side? Little d, which means it's what value? 7. Now, what's the only other thing I know in this triangle? One of the other sides is 12. Does it matter which side I put it? Doesn't matter, does it? If I put 12 here, what letter does that make this? Little e. What letter does that make this angle? Big E. If I put 12 here, what does that make this? Big E. Does it matter where I put it? No. I'm going to leave it. Ah, son of a motherless goat. I'm going to leave it there. So now what do I know? Do I have a pair of opposites? Do I have an angle on its side? Which pair do I have? I have 7 over sine 35. And what must that equal? What's the only other thing I know? I know E is 12. Am I putting my sides as numerators or denominators? Numerators. So this must be 12. And what's that? Sine what? E. Because I've got E right here. How do I solve that? Cross multiply. 12 sine 35 over what? 7 gets me sine E. Do I want sine E? No, I need E, don't I? So what do I have to do to this whole thing at the end of it all? Shift sign. If you get good with your calculator, can you do it right here with brackets? You can. Some of you aren't so hot with your calculator, so you're going to figure this out first, and then you're going to maybe use your answer key to shift sign. I want everybody to try and do it, because I have the answer. I know what it is. I want everybody to tell me E to the nearest degree, however you are good at doing it on your calculator. Lucas, you cannot say it out loud. Because. Yes, I said so. That's the only reason you need. Who would like to volunteer an angle for E for me? Joel. 80 degrees. Once I have E as 80, do I automatically know F? How? 180 minus 80 minus 35, which is 65 degrees. And then I only need the third side, yes? How do I find the third side? 7 over sine 35. Do I have to use 7 and 35, or can I use 12 and 80? 1 sec, Michaela. No, go ahead. By pushing on your calculator, you need to push mode, and make sure degree is highlighted. No problemo. Now, do I have to use 7 over sine 35, or can I use 12 over sine 80? You could use either one. Which is the better one to use? Why? Because it's already there and it hasn't been rounded. Okay? But you could use the 80 and it'll be close enough. So 7 over sine 35 equals what? Sine 65 over lil f. And then I do the same math, yes? Which is going to be 7 sine 65 divided by sine 35. Will get me f. And what is that answer? You figure it out. Yes, Lucas? 11.1. Can everybody use the sine law? When is the only time it works? No, it'll work all the time. That's why sine law is cool. It always works. It's really good with no 90 degrees. And what do you need to make it work? Sine law is no 90 degree, and I need a matching pair of angle and opposite side. If you can get that, you can do the sine law. Everybody cool? All right, I'm shutting up. I am, Joel. I know that you love the dulcet sounds of my voice, but I am shutting up. You now have 4 pages of textbook work. Listen to me. This is real life sine work. Okay? It's in a textbook, so the questions sound stilted and they don't feel real lifey. But trigonometry is one of the things in math that gets used in real life all the time. Okay? So I'm going to recommend certain ones here, and I'm going to recommend that you do at least those as always. All right? I am going to say 1, A, D, at least. A and D. I would suggest 2. I would suggest 3. I would suggest 5. I would suggest 10. Oh, that's interesting. On number 11, the page I photocopied has all the work written on it. So I'm not going to get you to do that. 12. And 21. And that's it for now. We're going to come back to that page after we do tomorrow's lesson. Okay?
I don't understand this question that you did. Like, why would you do that, and then why would you do this?
If you do that with your calculator,
Yeah.
because you put that negative in there, you're going to get that. Right?
Yeah.
Because you put the negative in there.
Oh, and then
Okay?
for this one.
Now, once you do that, you have to be aware that there's another spot in the circle where that cosine exists, which is down here, correct? So once you know that is 132.5, then you still have to find the reference angle and then add it there. Okay? Now, if you just do this without the negative, then you get 47.5.
Yeah.
So you know that's the reference angle. So once you have that, you know that since it's negative, it has to be over here, And you know that this has to be 47.5. So you can do 180 minus and 180 plus. It's just two ways of doing the same question, Jenny.
Okay.
Okay?
Yeah.
Because some people have trouble finding the reference angle. But you can always find the reference angle if you use positive. Because if you use the positive, you're going to get this. If you use positive, you're always going to get the angle in the first quadrant, right? Which means you're always going to get the reference. So no matter where you draw it, if I draw it right there, but I know my reference is 62, then I know this is 62, so I know the whole thing is 180 plus 62. Okay, it's just another way of doing it.
Okay.
Okay? You. Mm-hmm.
Can I do this on this question?
Yes.
Okay. Can you show me how?
Yep. So you set it up right. 10 sine 35 bucks. So you are going to need to go bracket. But you don't need to. But bracket 10 sine. Oh, no, you've got, you're backwards. You still have the backwards one. Okay. So you got to reverse this. 35 sine times 10 equals, not memory, 35 sine times 10 equals divided by 40 sine equals. Okay? You just reverse everything you see.
Okay.
All right?
Okay, thank you.
That's because you're punching it in wrong.
What?
65 sine 48 divided by 75. Okay, so bracket 65 sine 48 close brackets.
Like sine, like as a negative, like that, and then.
No, you don't need.
Oh my gosh. That's...
Divided by sine 75 close brackets. That's okay. It's notes, Amanda. It's okay.
May I go to the washroom?
Yes. You saw? Did you get some chowder at the Boston Garden?
I can't get the right answer.
How do you know? There's no right answer on this paper. You can't get her answer?
I can't get the same answer as them, yes.
All right.
Well, no, you put the answer on here.
So
35. You went. Okay, I tried to write it down, but I think
35 sine.
Did you just push the sign?
You just
Yes,
push
okay.
sine times
Yes.
10
Yes.
equals
Yes.
divided by 40 sine equals.
I think I forgot to push the
You
equals.
probably forgot the second equals because as soon as you say 40 sine, your
Yeah.
screen changes. Oh, I'm done.
Okay, thank you.
Your calculator won't give you an answer until you say, hey, calculator, I need an answer. That's what happens when you hit equals. And antisocial. Yeah. Now, you guys don't have the answers to this. Are we at a point where we'd like to see the first few to make sure we're doing it right? Going once?